When solving an equation, I want to find all the values of x that are in the real number system. If I want to solve this equation over here, I have to first take a look at the denominators and see if they are fully factorized. And then I'm going to use those factors as part of my LCD to get rid of the denominators of these fractions. Looking at my first denominator of 4x squared plus 2x plus 1, that is in fact fully factorized. If I tried to factorize it further, I would have got imaginary numbers, and I need solutions in the real number system. Going on to the next, I can see that that is going to be the difference of cubes. And in my third denominator, before I can even factorize it, I must get that bracket so that it is a reducing degree of x. So doing this, my first fraction stays as it was. So that is still going to be 4 all over 4x squared plus 2x plus 1. For my first fraction on the right-hand side, just concentrating on the denominator at the moment, when I factorize using the difference of cubes, the cube root of 8 is 2, and the cube root of x cubed is x. Keep the sign. The cube root of 1 is 1. In my second bracket, I square the first term, change the sign, find the product of the two, always a plus, square the last. And then in my last term, before I can start, I need to first switch those terms around. So I'm now going to have minus 7, and that's going to be times by 4x squared minus 1. Now you can see that you have a reducing degree of x, and you can spot that you've got a difference of two terms in the bracket. Also, you should have noticed that you now have two different signs in that last term, and a plus and a minus gives me a minus. So writing this out so that I can factorize that last denominator, it's going to look as follows. And then my last denominator is going to be minus 7, 2x plus 1, and 2x minus 1. As all of my denominators are now fully factorized, I'm able to find my lowest common denominator. My lowest common denominator must have the most of each type of factor. Now there are a lot of factors over here because there is a 7, which is a number factor, and there are 3 bracket factors. The first one is going to be 2x plus 1, 2x is the minus 1 is the second, and then this long bracket factor of 4x squared plus 2x plus 1 is different to all the other factors, so must also be included in my LCD. In my next step, I'm going to get rid of the denominators in my equation by checking what the old denominator looked like in comparison to the LCD and multiplying the old numerator by the new factors. In other words, when I do this, in the left-hand side, I'm going to get 4 times 7, which is 28, all times by the 2 bracket factors of 2x plus 1 and 2x minus 1. On the right-hand side, my old numerator of 4x plus 1 must be multiplied first of all by 7 and then by the bracket factor of 2x plus 1. And lastly, 3 must be multiplied by the long trinomial bracket factor of 4x squared plus 2x plus 1. In my next step, I'm going to multiply out the brackets and distribute the 28 into the first two and the 7 into the next. So multiplying out my brackets, the first two brackets, when I multiply them out, give me an answer of 4x squared minus 1. The next two brackets, when I multiply them out, are going to give me an answer of 8x squared, and then that's going to be plus 4x plus 2x, which is plus 6x, and plus 1. In the last term, I'm able already to distribute the minus 3 into the bracket, and so I'm going to do that immediately, and the answer is going to be minus 12x squared minus 6x minus 3. Now finally distributing the 28 into its bracket, I'm going to get the following results. 112x squared minus 28 is equal to 56x squared plus 42x plus 7. Still minus the 12x squared minus 6x minus 3 that I had before. As this is quadratic, I'm going to take all my terms to the left-hand side and add like terms. 112x squared minus 28 was already on the left-hand side, and so it remains for me to take all the terms that were on the right to the left. Each term, when it moves to the other side, changes sign. I've color-coded the terms that I'm going to be adding so that you can see which terms I'm going to be putting together. Adding the x squared terms, I get an answer of 68x squared. Adding my x terms, I get minus 36x, and then adding the constant terms, I get minus 32. Now maybe you've noticed, and it would be very convenient for you to do this, that there is a highest common factor that runs throughout these three terms. 4 can go into all of these constants. If I take 4 out as a highest common factor, my first term in the bracket becomes 17x squared. The second term, minus 9x, and the last term, minus 8. Because 4 is a constant, I can divide both the left and the right-hand side by 4. On the left-hand side, it cancels out, and on the right-hand side, if I have 0 and I divide that by 4, I've still got 0. At this stage, you can see that there is a nice trinomial that I'm able to factorize. Factorizing this trinomial, I'm going to get two bracket factors. The first one is going to be 17x plus 8, and the second is going to be x minus 1. And now I can see that I'm able to get two possible solutions. My first possible solution is going to be when x is equal to minus 8 all over 17. And my second possible solution is when x is going to be equal to 1. Remember though, because we had fractions, we have denominators, and I now need to take a look at both of these solutions and see if they are valid. I do this by looking at the LCD. As both 7 and the long quadratic factor could not be equal to 0, I have two restrictions that I have to consider. My first restriction is going to be when 2x plus 1 is equal to 0. In other words, when x is going to be equal to minus a half. And my second restriction is going to be when 2x minus 1 is equal to 0. In other words, when x is equal to a half. As neither of these restrictions is reflected in the solutions that I got, I have two very valid solutions that I can use to solve this equation.